Welcome to Interface. Today we have an eminent personality from IIT Chennai, Professor T. Pradeep. He is a person who works in water purification area. He is researching mainly concerned with nanomaterials used for water purification. He has initiated certain industrial collaboration programs also in that area. So, we will have some of his research experience. Okay, Professor Pradeep, what prompted you to do research in water treatment area?
Well, I have been a materials chemist for a very long time. Materials meaning these days it is mostly on nanomaterials. So, for a long time we have been investigating properties of matter at that length scale. Then obviously the question was, what is it good for? At that point, around 2002, a problem of pesticides in drinking water came up. So, we asked the question, what nanomaterials can do for pesticide removal from drinking water. So, we found that endosulfan could be removed by nanoparticles at a very low concentration using nanoparticles. This subsequently became a technology, and we tested a large number of pesticides in drinking water at very low concentrations. Then this was adopted by an industry. It became a product. It was sold. We got, we have been getting royalties. So, the question then was, is it only for pesticides? Obviously, we looked at a large number of other contaminants in water, diverse array of materials. This has then resulted in over a period of 10 years, it has resulted in a large research activity in the group.
It is heard that nanomaterials are very much useful in different areas.
Correct.
What is your opinion about it?
Well, nanomaterials and nanotechnology can find applications in almost each and every activity. Every activity of human life has some amount of nanotech in it. Clothing, detergents, drugs. Going from materials to drugs to memory to computers to whatever, the world is full of nano. But in a country like ours, when I was asking this question long ago, where will nanotech make a greater impact in our country? That, in my opinion, turned out to be water, and so I focused on that. Now, you would see exciting opportunities in sensors, exciting opportunities in agriculture, in healthcare, in consumer products, in food, in packaging, environment, air. So, I would say that opportunities are plenty. Impact in water will be more deeply felt than in other areas.
Okay, I understand that you have motivated some of your students to start some companies,
right,
in this.
Right.
What was the starting point then?
Well, as I said, I was working on the use of nanomaterials in the context of pesticides. That was my first technology, which was translated to industry. But then many other technologies came up. I realized that if we have to take any technology to the field, we must ourselves build the necessary interface. In a research laboratory, that is almost impossible because we make milligrams and grams of these materials. Testing them, their life cycle, productizing them, all this is beyond the scope of a laboratory. But at the same time, we have to take that push, otherwise nobody is going to take that forward. industry by and large doesn't want to work on developing a technology further from the lab to the market. If a product is there, they are happy to take it forward. Now I realize therefore that we have to build an interface. The best people to build that interface is our own students. And next door in the laboratory, we created a space wherein we could develop materials into products, test them over long hours, over very large volumes of water. Something like a typical laboratory, you will take a material in a column and pour a little bit of water, about 1 liter, and then ask what is the material removed, amount of contaminants removed, what is the adsorption capacity, etc. But in industry, you want to run this for 10,000 liters. So we developed a setup to do this for thousands of liters over long days for various contaminants, looking at the after effects. So this was built by the students, and it was then, it was ready for field implementation. So who will implement? So therefore the students themselves implemented. That was very well appreciated, so it was taken, well, people wanted it. Then who will put it up as a plant? Our own people put it up. So the gradually industry evolved in the laboratory. And along with that, we developed also systems, meaning institutional mechanisms to license patents. Along with that, institution was also changing. In fact, I would say that this whole thing became possible because IIT Madras is one such open place where you can come with an idea and you can do what you like. Institution is there with solid backing. I would emphasize that if it is there in a university setup, there will be more such efforts. Incubation industry is part of the Indian culture, but we have to create that necessary infrastructure.
Of course. Cost-wise, how far affordable it will be, your product?
Our water, we said affordable clean water is the theme. And affordability, at some point in time, I defined it as 5 paisa per liter of clean water. So if this is anything that is below that cost, I would say it is affordable. We are at about 3 paisa per liter now.
Oh, you have achieved that.
Yes. So it's it is in the right track right now.
Now, can you suggest any method for desalination of seawater, which will be?
Well, nanomaterials based desalination is probably not the right thing because seawater concentration is 35,000 ppm, which means that every liter of water you have to remove 35 grams of materials. This is 35 grams of salt. This is not a very much a feasible thing, affordable thing with materials. Now, that is where
you can check whether it can be feasible or not.
I know.
Future?
Yes. So instead of materials based approaches, we could think in terms of new nanomaterials based approaches. One such approach is capacitive deionization. With a small potential applied on 2 electrodes, which are nanomaterials based electrodes, you can separate ions, positive and negative, across an electrode and then get free clean water from that. We are working on that. So there are areas wherein nanomaterials per se may not be directly applicable, but nanomaterials with potential, with electricity, will be utilized. One such thing that I've been talking about is biology has to get into water in a big way. That is also nanotechnology. So assembling proteins, assembling molecules, so that water alone will transport through. New materials which are coming up, graphene and many others, have interesting opportunities. So desalination as a technology, nanomaterials have there is much more to do in that context.
Can you elaborate on biology utilization?
Biology, aquaporins are channels which are protein channels which transport only water with very high efficiency, very less energy requirement. If it is possible to create aquaporin embedded membranes, then you are by biomimicry, you could separate water from salt. This would involve not only biology, but also biology materials interface. These proteins should function in a membrane. They should last sufficiently long time so that a product can be made. So there are engineering challenges, there are biological challenges, there are materials challenges. Of course, productization is also a greater challenge.
Can you suggest any such methods for the household purification?
Water, as you know, is a regional problem as much as a national problem. There are in regions where there is water contaminated with arsenic, where there are fluoride contaminations. Specific issues in the context of in Kerala itself, there is a lot of places where there is iron contamination. Rajasthan, somewhere else there is fluoride, somewhere else there is arsenic. So nanomaterials based solutions are very much feasible when it comes to such regions where water is otherwise very clean, but you have to just get rid of arsenic. Now, for a long time, affordable solutions have not been available. Arsenic is now 102 years old. It was first detected in Argentina about 102 years ago. But an affordable solution implementable in the field has not been there. It is affecting about 80 million people. Now, today it is possible to offer that solution. Today it is possible to offer a fluoride solution. Like that, there are solutions possible. Such things exist today. Our government has implemented a few of those. So this is great. Looking at tomorrow, water is not just one technology solution. Water requires many technologies. Because water problem is diverse, solutions are also diverse. I am not a person to say that, yesterday's technologies are obsolete, today bring in something new. There is a lot to learn from the past technology, bring them together, interface with them, come up with new solutions. As I said, arsenic solution has not been there because we didn't make new materials. So now we have it. Combine that with many others so that the arsenic problem is a problem of the past. Likewise, we should implement new solutions. While that is happening, new solutions, completely new solutions also have to be looked at, like these aquaporins as we talked about. Now, water is, cleaning is one aspect. Water itself is scarce in this country. We need to harvest water. We need to conserve water. We need to develop new technologies which will utilize less water. We have to think of water recycling in a very different fashion. Can we think of homes with zero liquid discharge? Now, if you start thinking about it, we will be thinking about a new country. So, I would think that solutions for water should not be approached only from the perspective of these boxes that you will provide as solutions for water purification. Every other aspect has to be improved upon. So, around us there is a big, another problem. We are water stressed, but all our crops consume a whole lot of water. All our cotton it guzzles water. Our let us say sugar cane, it guzzles water. Now we keep cultivating it, we keep utilizing water, transporting this water rich crop or the produce somewhere else, what is called virtual water. We transport water in the form of products, we lose that water. We have to think about very new things. So as I said, water cleaning is only one aspect of a very large problem.
As you said, recycling is a very important area. Because there are various different companies, different laboratories, different concerns, hospitals, households.
Correct.
Where water is used and contaminated in different ways. So if you are able to get some affordable material with which it can be easily cleaned. Nowadays there are concerns which use expensive recycling methods.
Right.
Instead of that, if you can develop, that is, you mean new research groups should come up, isn't it?
Correct, certainly. There are solutions now available.
Solutions,
some solutions are available, some have to come up. You see, we are talking about new chemicals which have not been there till about 20-25 years ago. Lots of new different detergents have come. All of these is ultimately ending up in our 10 cents of land. So we have to think about new ways of recycling, otherwise our water resources are going to be contaminated.
New materials which will be holding water at the time of rain and
correct
and
sure.
discharging whenever it is.
Certainly, and also that certainly in agriculture. See, this is one area, agriculture. How about new kinds of pesticide, new kinds of pesticides, new kinds of pesticide delivery mechanisms? We have to think about the fertilizers that we are putting into the soil. All of them are actually leaching out, ending up in groundwater. So there are multitude of issues. One other thing that I wanted to mention is that materials are also required for sensing. India is a country wherein new technologies are needed for purification, but what about sensing? If water contains some contaminant, there is no way today to know about it without expensive equipment. Is it possible for a home user to know the water quality at home? For that, something new has to come up. This is very much relevant for the farmer. Now we need to know how much of humidity is there in the soil, how to better irrigate the soil. So the space of water, as I mentioned, the material space is very vast. Much more work is certainly needed.
Thank you, Professor Pradeep, for the valuable information you have given.
Thank you very much. Thank you. It was a pleasure talking to you.